Hi, I'm Nick.
I'm Bri.
I'm Hrishi.
And this is our project on Big Hero 6.
Fact or fiction?
Here's our scene for your viewing pleasure.
Society has rules!
Excuse me! Coming through! Tashi! Oh my gosh! You must be Hero! I've heard so much about you! Perfect timing! Perfect timing!
That's a whole lot of tungsten carbide.
400 pounds of it! Come here. You're gonna love this. A dash of perchloric acid, a smidge of cobalt, a hint of hydrogen peroxide, superheated to 500 Kelvin, and... ta-da! It's pretty great, huh?
So, pink.
Here's the best part.
Whoa.
I know, right? Chemical metal embrittlement.
What is hydrogen metal embrittlement? How does it work? And what are common uses for tungsten carbide? Hydrogen metal embrittlement. This is also known as hydrogen cracking or hydrogen-induced cracking, which is the process by which metal becomes brittle due to the introduction of hydrogen atoms into the material. Now we have three types of hydrogen embrittlement. There's HRE, which is hydrogen reaction embrittlement. We have HEE, which is hydrogen environment embrittlement. And then we have IHE, which is internal hydrogen embrittlement. HEE and IHE are very similar. Their only distinction between the two being the absorption process by which the hydrogen diffuses into the material. HRE occurs when hydrogen reacts with carbon to form methane inside of the metal. In the movie clip, they don't make it very clear as to which hydrogen embrittlement form it is. They refer to it as, Honey Lemon refers to it as chemical metal embrittlement, which is sort of an umbrella term for multiple types of embrittlement. The clip shown contains aspects of both HEE and the HRE. The aspect that parallels with HEE is the absorption process, which is by electroplating. The reason we leaned towards HRE was because the metal they chose was tungsten carbide. And in HRE, what normally happens is after the hydrogen is diffused into the metal, the hydrogen reacts with the carbon present in the carbon alloy, and this forms methane, which creates little pockets of gas in the metal, which builds up pressure, which when an external stress is applied, the pressure will release and it will explode.
What is tungsten carbide? Tungsten carbide is a carbon alloy commonly used in cutting utensils, armor-piercing shells, and jewelry. It has a melting point of 2,747 Celsius. It's really resistant to corrosion and doesn't oxidize in air at normal temperatures. And on the Mohs hardness scale, it is a 9, which is second only to diamond. That's a big ball. We're trying to figure out if the sphere is full, like completely full of tungsten carbide, or if it's only on the outer rim. So we estimated the sphere to have around a 1 meter diameter or a half a meter radius, and we plugged it into the volume of a sphere formula and got 17,315 pounds, which I don't think Honey Lemon can lift that weight. So it was hollow, which I had to go look up what's the volume for a hollow sphere and how to find the volume of the shell. It's that formula. Plugged in all these numbers. The numbers are correct, I promise you, and we get 0.288 centimeters for thickness, which seems like a viable thickness.
What is she doing? So we start with our 400-pound ball of tungsten carbide, and outside of that, she starts with a dash of perchloric acid, adds a smidge of cobalt, and then adds a hint of hydrogen peroxide, heats it up, and gets this big gas, adds electricity to electroplate the ball, touches the ball, and then the ball explodes. So she starts off by adding the cobalt to perchloric acid. This is the initial perchloric acid we're shown, which is incorrect because perchloric acid is known to be a clear substance. The perchloric acid flows along the tube, and she adds cobalt, which changes with the perchloric acid to form cobalt 2 chloride, which is properly depicted as blue when it is not hydrated. She then adds her hydrogen peroxide, which decomposes into water and hydrogen. Cobalt is not reactive with water at room temperature, so there will be no other reaction that will occur until the solution is heated. But when she does heat it, the water hydrates the cobalt chloride solution, and changes the cobalt ions into hexaaqua cobalt ions, which are known to be pink when hydrated. And here's the change on the screen, and here's the change of unhydrated on the left and hydrated on the right. So it's pretty realistic.
Electroplating. Electroplating is commonly used to coat metals, such as coins. It is a subclass of electrolysis, which we've learned this year. In the movie, what occurs is Honey Lemon sprays the gas on the tungsten carbide, and when she applies the electrical charge, the pink solution, the gas, is oxidized, and the tungsten carbide is reduced, which, as similar to shown in the picture, it forms a coating around the tungsten carbide. And this is the portion that most parallels HEE, because whenever HEE occurs in real life scenarios, one of the most common forms by which the hydrogen is absorbed is by electroplating. However, when the hydrogen diffuses, because they chose to use tungsten carbide, we thought it most paralleled HRE, and that's why whenever Honey Lemon taps it, she applies an external pressure on it, which causes the ball to explode.
Is it fact or fiction? It's facts, no cap, no printer. This clip isn't like perfectly grounded in chemistry principles, but it's pretty close to what would happen in real life. The only issues we could find were the colors of solutions that Bree talked about, and that it didn't specifically go with one type of hydrogen embrittlement. It kind of switched between two. And also, the ball may not pop that perfectly and dramatically. Like it might have, I don't think it would be a perfect all-around symmetrical pop. But overall, the steps to reaction and the end result seem like they could totally happen in real life.
Thanks for watching!
Cool beans.